So in number 5, we're given kind of a sparse amount of information. We're given the graph of a line, and 2 points have been labeled for us on that graph, just as though to say you can trust that the line goes through the point that's indicated. That would be the points that have whole number coordinates at the values that are indicated. So one of the hardest things about graphs is that we want to trust our eyes when we see it go through a certain point. One of the things that I saw some people do on this problem is that they looked at it and said, well, if I want to know what the y-intercept of this line is, I should just be able to look right there where this line crosses the y-axis and say, well, clearly this crosses the y-axis exactly halfway between 5 and 6, and so we're going to say that the y-intercept is 5.5. And for those people, I was throwing cool water on that left and right. That is a slippery slope. Because it very well might be that the y-intercept of this line is 5.5, but it might not. It might be 5.46, or it could be 5.54. Who knows? Graphs can only be so accurate. They speak 1,000 words, but they speak them in kind of these muted tones, where you can't exactly trust the values that you see on them unless you're specifically told otherwise. So in this problem, the only values that we can trust are the ones that are labeled for us, specifically the coordinates of the 2 points which have been called out on this graph. The point over here on the right having coordinates 1, 6, and the point over here on the left having coordinates -4, 3. So this is really a question of how to find an equation for that line which passes through the 2 points 1, 6 and -4, 3. So what's your strategy? How are we going to find an equation for the line that meets that criteria? Where do you start? What's the first thing that you want to find? All right.
The y-intercept.
The y-intercept. So I'm going to actually recommend that you find that second and not first.
Find the slope.
Yeah, I'm going to say find the slope first. And the reason for that is that we don't really have a lot of information that would let us find the y-intercept first. We do, however, have enough information for us to find the slope right out of the gate. Because all we need to find a slope is a rise and a run. All we need for a rise and a run is 2 points, and we happen to have 2 points. Once we find the slope and we find the y-intercept, then we can just write our finished equation, which weirdly is a step that sometimes people forget. But when we write that finished equation, we can use y equals mx plus b to do it. Y equals mx plus b. And so our job is just to figure out how to fill in that m and that b. But finding the slope should be priority number 1. So how do we do it? Before we found the slope by rearranging an equation and then pointing at the slope in the equation. Here we don't have an equation to start with. We just have this graph and the coordinates of 2 points. So how do we find the slope from the knowledge of those 2 points? Debbie?
Y2 minus y1 over x2 minus x1.
Yeah, here's where that other formula comes in, the rise over run formula. It tells us we can find the slope by subtracting the 2 y-coordinates of the points that we know and subtracting the x-coordinates of the 2 points that we know in the same order as the y's, and then dividing those 2. And that will tell us what the slope is. The number of formulas to memorize as such for this course is fairly small, but this is definitely one worth knowing, the rise over run formula. So, how do we navigate this formula? What should I use for y2 and y1? Where do those come from? Our 2 points. So let's say 3 is my y2 and 6 is my y1. Just arbitrarily. I could have done it the other way around and we could still end up with the same answer. But if I do it that way, then I'm subtracting 3 minus 6 in that step. If everything is labeled as it is here, then what is x2 going to be? -4. So the most important thing is that the x2 that you use and the y2 that you use have to go together. So if I use 3, the y-coordinate of my point on the left as my y2. Then I also need to use the x-coordinate of my point on the left as my x2. So the quick consistency check is that the numbers which are above one another here when you write out the rise over run formula should belong to the same point. So negative 4, 3, negative 4 and 3 came from the same point over there on the left. And then likewise, what will I be subtracting? 1. That's the y-coordinate of my other point, x1 right there. Okay. So to find the slope, I just need to subtract 3 minus 6, that's negative 3, and divide it by negative 4 minus 1, that's negative 5. What's negative 3 divided by negative 5?
3/5.
It's just 3/5. You can cancel the negative signs, but there's really not much else to do there. So here we've decided that the slope of this line is 3/5. Why does that slope make sense given the picture on the left? Rise over run. And what does the number 3/5 tell us that we can sort of quickly identify makes sense in our picture as far as which direction the line is going? It's going up because the slope is positive. Yeah. That, by the way, is an insight you want to hang on to all the way into calculus. Having a positive slope means that it's going up. And sure enough, over here on the left, as we go from left to right, our line is increasing. So, great. So the slope of our line is 3/5. So what can I fill in my finished equation right now? M. I can put the number 3/5 right there in the M box, right, in the slope box. So y equals 3/5 x plus something. So far, that's what we know our answer is going to be. The only question that remains is, what is the something? What is that empty box over there at the end? It's our y-intercept. So if we find our y-intercept, then we know how to fill in that box. If we fill in that box, then we know what the y-intercept is. And so that's our end game now. The problem is, there's not really a good way to find that intercept, except to just sort of trust our instinct here. And what I mean by that is we have now an equation, y equals 3/5 x plus b, which relates together three different quantities, x, y, and our unknown intercept, b. So I can use this equation to determine the value of any one of those three things by specifying for it, supplying for it, the values of the other two. So if I want to find b, I have to supply this equation with x and y. Where can I get a value of x and y that I can supply into this equation that will let me determine b? Just take one of the points. One of the points that we know is on this line. And if our slope is correct, it won't matter which point we choose. So choose whichever point has easier coordinates to work with. I'm looking at 1, 6 and thinking, they're both positive. Let's maybe use that one because it might help us a little bit. But it shouldn't matter, again, which point we choose, as long as our slope was accurate. So let's say I choose 1, 6. Then, in that example, I'll be substituting a 1 for x and a 6 for y into this equation. And doing so is going to give me an equation, 3/5 times 1 plus b, which now the only unknown in that equation is b, and I can use the tools of algebra to solve this equation for b. What's 3/5 times 1? It's just 3/5. Multiplying by 1 is kind of simple, so that was maybe a good reason to choose 1, 6 as the point, because multiplying by the x was really straightforward. So how do I get the b by itself in this last equation? Subtract 3/5. From left side, from right side. 6 minus 3/5. Quickly doing out that fraction arithmetic over here in the corner. Well, we have to put 6 on a denominator of 1. What's a common denominator for firsts and fifths? 5. And so I'll have 30 over 5 minus 3 over 5. And 30 minus 3? 27. 27 over 5 doesn't reduce. So what I end up with is 27/5 equals b. And that means, what? How do I finish?
Plug it in.
Plug it in. Put 27/5 into our remaining empty box in our equation where we were looking for a b, and now we're finished. It's an easy step to remember if you're doing a multiple choice question, but sometimes in the heat of the moment on an exam, you get so excited that you found b that you forget to write that finished equation, and then the point-grubbing monster comes after you. So don't fall victim to the point-grubbing monster. Make sure you write your finalized equation after you've found both m and b. So by the way, 27 over 5, as a decimal, 5.4. So if you thought 5.5 was the y-intercept, you almost had it. You were 1/10 off. But 5.4, in fact, is the accurate y-intercept for this line. So the overall strategy, the shape of this problem, I think is pretty straightforward. As long as you remember to find your slope first, and then use that slope along with your template to discover the y-intercept, that's really all there is to it. And in some ways, finding an equation of a line from knowledge of 2 of its points is the most universal skill in all of understanding and navigating linear equations. Because along the way, you kind of recall what it is that the slope means in the first place, the rise over the run, and then you use all of your algebra skills at your disposal to then shake out knowledge of the y-intercept as well.